Hello, I'm Mrs. Daywald. Welcome to the lesson on polygons in the coordinate plane. This lesson is mostly about graphing different points, and while you're graphing different points, you are also often going to be finding the perimeter around the points or the distance between each of the points. Hopefully you have already graphed the square on page 410. If you are not on 410, please go to page 410 right now. In order to find out the amount of fencing that the garden will need to enclose this garden, we need to know the perimeter of the garden. I found that many students have trouble with this because they never know whether to count the spaces or to count the lines. We're not going to count either because our points are each one is directly in line with the other. We are going to be able to use our new skill of using absolute value in order to find distance between 2 points. So right now I would like you to write the ordered pairs next to each of the points that you have graphed. Please pause the video so that you're able to do that. Now we are going to use absolute value in order to find the distance between each of the points. We're going to start off with W and X, and so those were the first 2 points that we had graphed on our coordinate plane. Remember, I'm going to use different colors for each of these so that we know what we're doing. You need to look at the 2 coordinates that are different. X is the same in this case. I'm not going to cross it out because we're going to need it later, possibly. So, sorry, Y is the same in this case, so we're going to use the X coordinate. I have -3 and +3. Because -3 and +3 have different signs, I'm going to add the absolute values. The absolute value of -3 is 3. The absolute value of 3 is 3. So the distance between those 2 points is 6. Next, I'm going to find the distance between X and Y. I'm going to use red for this one. The one that's the same, we're not going to use. It's the same, so the X coordinate is the same. The one that's not the same is 3 and -3, -3 and 3. So I'm going to take the absolute value of -3, the absolute value of +3, because they have different signs, I'm going to add them, and then I know that 3 plus 3, the distance between those 2 points is also going to be 6. All right, I'm going to give you a second, pause the video, and I would like you to figure out the distance between Y and Z using absolute value, and also figure out the distance between W and Z using the absolute value. Hopefully you did that on your own, and you have checked your work, and you know that the distance around the entire garden would be 6 times 4. So how much fencing will this gardener need to enclose his garden? Well, we know each side is 6, and 6 times 4 is 24. So he will need 24 yards of fencing to enclose his garden. Now, how do we find the area of the garden? Once again, we know that the area of the garden is, or the formula for area of a garden, well, if the garden is a square, we know area of a square. If you look at your formula sheet or your PSSA reference sheet, we know it is S, and that is a cursive S, squared. So S squared, S means side, so side squared is 6, and 6 squared. Be careful. 6 squared is not 6 times 2. 6 squared is 6 times 6. So the area of my garden is going to be 36 yards. And we know that area is square area, so it's 36 yards squared. Lastly, we did do the last one, hopefully. The clothing designer makes letters for varsity jackets by graphing the letters as polygons on a coordinate plane. One of the letters is polygon A, B, C, D, E, and F. The vertices of the polygon are, and they're as follows right there. Each grid unit represents 1 inch. Graph the points on the coordinate plane and connect them in order. Identify the letter formed, then find the area. So we all know that that letter is L, and I have not finished labeling all of my letters, so I'm going to do that now. And now in order to find the area of this shape, we are going to have to think about what we need to do first. The first thing we're going to have to do is divide this shape. The reason we have to divide it is because we don't have a formula for the letter L, but we do have a formula for two rectangles. So I divided into two rectangles. I knew the area of my rectangle formula is going to be length times width. So I need to now identify the length of each of these rectangles that I have formed. We can do that by simply counting them, or we could use absolute value. For this one, we're just going to count them. And I'm going to show you how to count the distance if you actually have a graph in front of you. You're going to start at the point that you're on. We're going to do BC. So the distance of B to C, we're going to start at B, and we're going to, I call it leapfrog. 1, 2, 3, 4, 5, 6 units. Remember, units is distance, and that's always going to be a positive number. Distance is always positive. So it's 6 units from B to C, so that's the length of my lower rectangle. And if I go from B to A, I have 2 units, so it's 6 times 2, and the answer there would be 12. And we're going to stop there for just a moment. And now we're going to find the distance. And I like to put a little circle in the middle just so I don't forget what I did. Now we're going to find the distance between E and F. I could use absolute value, or I could just count them. Starting at F, I'm going to count up. Leapfrog method, not very mathematical, but it works. 1, 2, 3, 4, 5, 6. So E to F is 6 units. Length times width for E to F. And I call that length, even though it's going up, it doesn't really matter because multiplication is commutative. And from E to D, 2 units, and 6 times 2 is 12. And now in order to find the entire area, I need to add the 2 together. So the area of the 2 rectangles would be 12 plus 12, which is 24. And then I always go back up to my question to look for what my label would be. If there's no label, it's units. But in this case, it does say it was inches. So I'm going to do inches squared. Remember, area is square area. So the answer would be inches squared. Great job, and wait for the next lesson.